segregation model integrated with the SIR disease spread model. For the first part, I have already finished the segregation model, and the model was set up in the NetLogo interface. I have added a few extra features based on the original model. The first one is the canvas size. We can control if the simulation is run either on a smaller scale or a larger scale. Second is I added two types of agents, and that the number of the initial agents was going to be decided by the overall density and the map size. The third one is I have added an additional parameter called neighborhood radius. That basically is to decide at what range you consider the surroundings to be your neighbors to be taken into your consideration. I added the visualization, the graphic demonstration, which we're going to see in a minute. So when the simulation runs, it will start with a very chaotic, scattered, non-organized position at the start, and then each agent, based on their preference of whether they like to live with people that are more like themselves or not, they will choose whether or not to move to the other places. So this is when they start moving, and the unhappy number, the people that are not satisfied with their neighborhood number would keep decreasing, and finally reach a final stage which they form this kind of solid pattern. They have their own habitat and keep a very, very clear distance between different types. So I have done a few model validations. It always starts in this position. As you can see, this is a different graphic style, which is the happy and sad face, resembles whether this agent is satisfied with its surrounding condition. It has typically three types of end position. This one is a typical segregation position, which, as you can see, two types form its own territory. The other is it forms a kind of a mixture territory, which only happens when we set the agent to be more, to prefer more of a diverse neighborhood. And third kind is an endless position, which is nobody is happy with its surroundings, so they keep moving and never reach an equilibrium. So the next step is I'm going to integrate the SRR model into the segregation model, which I have already done some foundation work. I've created two types. That's for sure. I have different neighborhood area definition, which could be related to how the disease is going to spread, because the disease spread based on contact, right? And the third one is a visualization feature. So the happy and sad face could be potentially turned into a graphic showing whether this agent was infected, recovered, or in a healthy mood.